All right, and moving on to the next topic of the day. And next is Kun Somlak Wannarumon Kielarova. She will be here for the From Jewelry Designs to Silver Metal Injections Molding Process.
Good afternoon. I'm Somlak Wannarumon Kielarova from Naleswan University. Today, I and my team would like to present our research in the title From Jewelry Design to Silver Metal Injection Molding Process. In our work, the research is come from we found the defects that often occur in investment casing process, and we're looking for the new method to solve this making process to get better quality of jewelry item, as well as we would like to get a better competition in world market with a good quality of jewelry items. In our objectives, we would like to reduce defects in jewelry making process and to enhance the jewelry making process in global commerce level. Now I would like to show you about our methodology in the concept of design for manufacturing. In our work, is related to various theories. Start from designs. We use generative designs in this work, and we integrate with jewelry designs. We study in metal injection molding. We study in silver powder production and finite element methods. We integrate all theory in a single framework that integrates things from generative designs until silver metal injection molding process and mold design. From this methodology, we spent around 1 year, and the coming results is shown in the next part. It starts from we choose the test part. We choose a signaling because the signaling is quite simple. Therefore, with the simple parts, we can clearly understand the parameters that may affecting to this study. We start with the develop generative jewelry designs in the rhinoceros grasshopper. We create the program, the small program on that platform. We start with design the signaling in 3D model, and we parameterize that 3D models. We get the parameters that affect to the shape of the signaling. So when we change the parameter, the shapes of signaling is changed. Now we show you how the signalings can change their shape. In the program that we developed, it allows you to choose the ring size you prefer, and the ring is changed. Follow that you choose the parameters. You can control the shape of the ring, either the head part or the trunk part. Also the detail of the head part, you still can control the width, the height, the range, as well as other details that depend on you parameterize that CAD model. And now I will show you how we can use finite element method to simulate the injection molding process. We use that CAD model that we obtained from the previous stage, and we design the mold for that CAD model in the SolidWorks platform, and then we simulate that process in size, and we define the process parameter as well. Here we'll show you when we inject the material inside the cavity, the shape of the ring is formed by this way, and then we can see the result. Here, the result from the simulation can show you that the jewelry item is will compete or not, or where else on the jewelry item may occur the porosity, or where else can happen the air trap So this kind of thing, we can protect the defect before go to the production process. This process that I explained, we call it design and process parameters optimization. As you see, we start with the jury designs, we go to more designs, and then we simulate the process parameter in the software, and we analyze it. And if still have some defects, we improve those process parameter and redesign the jury item. So this process is iterative run until you get the best solution. Then you choose that, go ahead to the production process. Now we go to the powder production. In powder production, here in this study, we produce the silver powder alloy mixed by gas atomization techniques. This machine is built and installed at Department of Industrial Engineering, Rajamangala University of Technology, Isan. And now we show you about the compound preparation. We screen and analyze the compound and mix with the polymeric binder in different ratio and use it to test. And here we show you the powder is formed in this shape, the test piece made by various sets of temperature and pressure condition. And we use it in testing mechanical property and analyze it. We perform to evaluate the green strength of the piece test. And the result show you on the screen in form of bar chart. Now we go to the solvent deblinding process. First, we start with the hexane. We soak the test pit inside hexane. We store the hexane and heat to the 40 degrees Celsius for 20 hours. And we dry on the air and we heat it in the oven. And the result show you on the screen, the specimen is melt after soaking in hexane and heating to 400 degrees Celsius. And when we change from hexane to petroleum ether and heating to different degree, it leads to 800 degrees Celsius. And it's still melting, but something interesting happened. The color of the test piece is become more gray and more beautiful than we use hexane. Anyway, we go ahead to the water deblinding process. You will see before and after deblinding process. The surface is after deblinding process is more smooth, but it still needs some improvement because it still have some big porosity. Now we show you the more that we simulate with the software, we use that process parameters to create this mold for the MIM process. We use that mold set up in the machine and we inject the powder inside the mold. We obtain this thickness link as the test link that we designed before, and it shows us that the result is acceptable. Now I would like to bring you to the conclusion part. Here in this research, we integrate generative designs with the metal injection molding process to concern designs for manufacturing. We counting manufacturing conditions since in the design stage. Generative design with the input parameters can automatically generate a 3D CAD model of signet links according to the conditions and limitation of MIM and mold design. Silver powder used in this study is produced by gas atomization technique. And we see that binder system still need more study, and we will keep this result for further study. And from this research, we prove that MIM has high potential to make jewelry items and is good for large production run. And now we would like to thanks to our grantor, the James and Jury Institute of Thailand, or we call GIT, that support the grant for this study. And we gratefully thanks all participants for this collaboration in this research. For more information, you can please feel free to contact me with the mobile or email. Thank you very much for your attention.
Thank you. Thank you so much to Kun Somlak for the informative tours. All right, ladies and gentlemen, and next will be the oral presentations from the Thai experts.